So again, with my last question, R changed in a certain number of centimeters to a certain number of centimeters, and I wanted to find the corresponding change, or at least approximate the corresponding change in volume measured in centimeters cubed using differentials. Notice how different this question is. The radius of a sphere increases by a certain percent. Can we use differentials to approximate a certain percent change in volume, not even knowing what the initial radius was? And I think the answer is yes. But before we do it, if I want to talk about x changing, then I guess I can refer to the change in x as such. But if I want to talk about the percent change in x, I think I've got the ratio of the actual change to what the initial amount was. So when I look for a certain percent change, I'll rephrase that. When I look for the percent change in some variable like x, I'm really looking for dx over x. Actual change divided by actual value, so my units of centimeters cancel. Get a percent change. All right, here I go. Just like before, let's look at differentials. Now, because I want the percent change in volume, let me divide both sides by volume. Here's what I have on the left-hand side. Now, on the right-hand side, I'll still divide by volume, but volume can be interpreted as such. Now, with a bit of cancellation on the left-hand side, doesn't that give me this? These are V's. These are R's. Ah, but I knew R's change or increasing, I should say, by 2%. That means using differentials, I'm seeing the corresponding volume changing by approximately 6%. A bit more sophisticated of a question, I think, but I need you to understand the distinction between those two types of changes.